Welcome to our video. My name is Freddy Gilber and today we will present the Iodine Vapour Test, a quality test method for high accelerated climatic stress testing of high voltage electronics such as power modules and LEDs. High accelerated testing is used to detect weak points of an electronic assembly and process indicators for the potting. There are three different options. The first option is HALT, standing for High Accelerated Lifetime Testing. This test method analyzes the risk for lifetime-related thermal mechanical failures and the susceptibility against vibration, shock, and temperature. The second option is HAST, meaning High Accelerated Stress Testing. This method inspects weak points or process indicators of production to avoid early failures during operation. The third option is High Accelerated Climatic Stress Testing using the Iodine Vapour Test. This test is used for the qualification of electronics with transparent potting. It localizes weak points with regards to climatic stress and harmful gases such as cracks and penetration paths in the potting or adhesion weak points between the assembly surface and the potting material. How does the Iodine Vapour Test work? It is an alternative to harmful gas reliability testing, and we will show how to conduct it using a DCB power module with a silicon potting. While conventional harmful gas tests are expensive, require the use of toxic gases such as hydrogen sulfide or chlorine gas, and usually take up to 21 days of time, the Iodine Vapour Test is fast, safe and cost-effective. A beaker is filled approximately 1 cm high with a ZESTRON resin test indicator, which is an iodine solution. This indicator is reactive but also easy to handle. The power module is fixed inside the beaker above the iodine solution, so that it gets surrounded by the iodine vapor once the beaker is heated up. The beaker is sealed with a parafilm, a flexible film composed of waxes and polyolefins, and is put on a heat plate in a fume hood for half to 1 hour at approximately 65 degrees Celsius SAM temperature. Iodine evaporates at increased temperature out of the saturated iodine solution, and it resublimates when cooled down again. After between 30 minutes and 1 hour, let the beaker cool down and remove the power module. Rinse it with DI water and dry it with compressed air. Now we can inspect the power module by microscopy using interference contrast. As we can see here, there are adhesion weak points of the silicon potting, which are visible due to the reaction of iodine with the copper surface. Looking at the close-up, we can better see the copper iodide, the bright dots, that has been formed in regions with insufficient potting adhesion, especially in the area of the solder joints of the chip. This can be due to copper tin formates, sulfur compounds, or flux residues, which are an indicator for insufficient cleanliness prior to potting. Let's summarize the last few minutes. The Iodine Vapour Test is a quick accelerated stress test for quality validation and an alternative to harmful gas tests. The equipment cost is low, and at the same time we have a high operational safety. And it is especially helpful to check the transparent potting on power electronics such as power modules and LEDs, since the corrosion products of copper and silver are perfectly visible through the potting material. Should you have any further questions or need advice concerning the interpretation of the results or support to improve the potting process, you can contact us via the email address shown at the end of this video. Thanks for watching and goodbye!